Good morning, everybody, and let me get the screen up. Today we are going to be doing a walkthrough of regression again. We did one the other day for class, and this will be our second walkthrough, our second data set. So please make sure, as always, for the lab days, you've got the data set for the lab downloaded. As the video goes on, there'll be places for you to pause to solve the work that's going on and then to start the video again and check your answers. We are sort of heading close to exam 2. I mean, it's not like it's right around the corner, but it's not too far away. So just be aware that for exam 2, we're going to be having, in terms of formulas, correlations, regression, z-scores, of course, are on there. That's sort of where things begin, the normal curve stuff. And the materials I'll be covering later this week and next week, heading towards exam 2, will be a little bit more of the conceptual stuff. The third exam is going to be the one that is going to break the bank on the analyses. And there'll be 3 t-tests and the analysis of variance. I don't know if means testing makes it to exam 3 or I pawn it off to exam 4, but exam 3 is going to be the one that you're just going to have to be calculating the entire time on exam day. That is without question the roughest in terms of formulas. We're still sort of getting in that. So there'll be for exam number 2, the correlation. So 3 of them you have to know, plus regression, plus the factual stuff that sort of bookends these lectures. So this is our last formula we'll be using for exam 2. There might be like a little tiny one thrown in, but we're not going to be doing the t-test until exam 3. So that will be where the material will end. And of course, I will let you know where the end is in terms of preparation for exam number 2. Exam 1 and the homeworks have been graded. I haven't gotten the homework 3s in yet, but I'm going to try to get those out at a little bit better pace now that I'm sort of on. I understand the schedule of getting everything ready online a little bit better than I did in the beginning, and I got myself in a bit of a hole. So I'll be getting that stuff to you a little bit quicker. I do want to say that so far there doesn't look to be anyone who is in trouble. Anyone can certainly tighten up what they're doing, but as the moment of exam 1, so exam 1, the homeworks, everything that's been graded so far, there's no one who is what I consider a risk at this point. So congratulations, that's fantastic. Not necessarily common. There's typically 1 person or 2 people at this point who are already in the woods, and you guys are not. So that may change when I see homework 3, but so far you guys are doing great. You're not a class that's causing me to have any sort of worry. Now, that doesn't mean that you don't have questions, and certainly Sammy's available through the ARC, but you also can go ahead and email me or schedule a Zoom conference with me if there is something that is problematic for you. But again, I would say always go through the the video. Certainly the lab video makes a little more sense because it is a walkthrough of each of the problems. And I think that that's what most people, if they're struggling, are going to be there. If there's any problem that your class is having, let me just count off the 2 of them. The first one is that there is a carelessness issue, certainly not the worst group I've ever seen, but for the most part, if someone is is having some trouble, some part of that has been in the simple squaring and adding, subtracting sort of thing. I did that on the key I sent you for the homework. So it's not that I don't know that which I talk of, but the idea is that there is sort of a carelessness sort of issue that's hurting some of you. The second, and I think we're kind of past it at this point, at least on the exam is where it became a little bit more noticeable. I recommended a particular sort of standard deviation formula because it gets rid of some of the hurdles you have with other versions of this. Most of you used the version that I recommended. Some of you did not. There's about 2 of you that did not, and both of them seem to have mistakes made doing standard deviation the old way. So again, last time I'm going to sort of rally for it, but the method of doing sum of squares and sum of squares into standard deviation, that is really the better option because you don't have all the decimal points and adding and subtracting, which is where the mistakes are likely to be made. So the last attempt to sort of convince those people to change the way that they're doing standard deviation, because they did introduce error into their work. And one of the people had probably the highest grade in the class until we got the standard deviation, and then it went south. So, you know, I can only do so much. I'm not going to, not necessary that you change, but be aware that that other formula, the ones that sort of, the ones that I'm not sort of supporting, they do work, but they're more risk of mistakes. So do it, don't do it. I'll wish you the best either way. Okay, so let's get into regression and let's see what we have. So here's the data set that you have. And in this one, we are predicting somebody's grade based on a number of practice problems. So in terms of the question set up, I would say that a teacher gave out a series of optional problems to work on. And again, because it was optional, you're going to see people doing a number of different things in that. This is actually based on a classroom experience I had. And you had 100 problems that you could work on, and then you're allowed to do as many or as few as you want. And this was a pretty decent, this isn't the actual data, but this is a pretty decent representation of the results that I got. And that's that some people do very little. Some people do all or almost all of them. And the ones who tend to do most of them tend to do a little bit better on average. So this was correlation. I would expect a positive correlation. And a fairly strong one. The less that you do, so we're going to start you down here, the slope of the line going up. And so for our slope, we'll probably see something fairly similar. So, but again, it's not going to be perfect because some people who understand the math don't need to do all the practice problems. So it's not a clean, it's not just the problems that teach you how to do math. Some people understand how to do it with just 1 or 2 tries. So it's never going to be a perfect resolution, but this is sort of what I sort of saw just in terms of the questions. So people were allowed to work on as many or as few problems as they wanted, and then the grade that they got in the class. And obviously this is of course made up as well. These aren't real people at this point. So what we're doing is can we, if we want to go with the strategy, this was something a teacher did every year, give them the option of working on these problems. What would you predict? Can you predict from the number of problems that somebody decided to work on? A metric which would be, how would we describe it? Something like, I always want to go back to grit because that's a word that we always throw around, but people who sort of do the work, the sweat equity that they put in, does it have an effect on the overall grade? And that's really what we're doing here with this one. So predicting from X number of problems that were worked out of 100 into the grade a person got in the class. Okay, and of course the box is sort of covering up the formula. So underneath the formula, of course, is a formula for slope. And step 1 is always going to be, whenever we're doing this, write the formula out. I haven't really seen any problems with this in the class, but we really haven't had any problems. This will start to show up. Oops, I went forward. This is going to start to show up as we get to correlations, because that's the first time that you're really asked to write out a regular formula rather than something like the standard deviation. But you guys were doing it. Sometimes students don't, and I don't understand it, because you get a point given early on in the semester for writing the formulas down. And at the end of the semester, you're not getting a point for it, but you're losing a point if it's not there. So there's always points on the line if you don't write out the formula. So always write the formula out. It would tell you what columns, etc., that you have to do. So if we didn't have the other walkthrough, we go through the steps again. I would say write the formula down. First thing I'd want you to do is look to see what columns you would have to calculate based on what's in the formula. So looking at this, we see for the formula for slope, the first thing is the sum of the XY column. So of course, we're going to need to calculate an XY column. Sum of X, sum of Y. Okay, those columns are right there. We know to sum those up. We need an X squared column. So we're going to have to square the values of X and then sum that column. And for this one, again, remember, we don't need a Y squared column, so we're not going to waste our time doing it. But just having that formula there and having it written down tells you what columns you're going to have to calculate. Now, there's a second formula for the Y-intercept, and we might have to do more at that point. But for now, these are the columns that we have to calculate. So I have the part ready for you, and your task now is to fill out the column. So here's our XY column. Fill out the values, sum, and our X squared column, fill out the values and sum, and of course then sum the columns for X and Y as well. So go ahead and complete that part of the table, and then come back after you're finished and we will compare results. Okay, let's see how we did. And again, if you have the sum total wrong, look up at the column to make sure where that mistake was made. Whether it's an addition problem, you just didn't sum it correctly, or it's a multiplication problem, you squared incorrectly or something like that. So here's the data we have for our different columns. And again, we're really concerned with the column totals. These are the things that go forward. So some of the X column should be 759, some of the Y column 42.1, some of the XY column 2,827.20, and the X squared column 55,417.00, if I'm doing the things I'm supposed to do. So now we're going to take those things and plug them into the formula. We have our column totals and everything we need to pull this in. And of course, our N here is number of participants. Remember, one participant giving 2 scores. When we're looking at N, we want the number of individual people, not the number of scores. So this is why you need to know if it was within or between in part 1. This is obviously one person giving 2 scores. So the number of people are 14. So our N is 14. All right, go ahead and pause again. Take those values and plug them into the formula. You can go ahead and solve after that because that's going to be the next step, but I'll pause, do the next step, and go on. So put them into the formula and then come back. All right, here's what your formula should look like. If anything's wrong at this point, don't go forward. Should be on the top of the fraction, 2,827.20 minus the quantity, 759 times 42.10 divided by 14. And then on the bottom is 55,417 minus the quantity, 759 squared divided by 14. All right, so go ahead and do that, and then come back and let's see what you have. Okay, and then you solved it. You should have gotten a slope of 0.038. So this is a slope of, if this was a percentile, we would turn into 3%, but it's not. It's a slope. It's the angle of the line. So there is our slope of the line. Again, as we talked about the last time, going from a larger number to a smaller number, your slope is going to be smaller because that's the multiplier in this. So we're going from something that goes from 3 to 100 in the first column, the X column, and we have to end up with a prediction that's sort of anchored between 0 and 4.0 for a grade point. So going from a large scale to a small scale, the slope, which is again the multiplier in this, that is going to have to be a small value. If we did the opposite direction, started with Y and predicted towards X, the slope would be a lot higher value because we'd have to go from something constrained from 0 to 4.0 into a range that goes from 0 to 100. Okay, so in that case, you can sort of expect that your slope should be either big or small, looking to see the direction that you're predicting to, whether going to a very small number or going to a large number. It's not a great double check because the value can always be off, but it tells you if you're in the right ballpark. So this one would have to be, the slope would have to be a small value to go from a large range into a small range for a prediction. Okay, so our slope is 0.038, and we just plop that up there. And then our formula for the y-intercept, again, since we did the slope the way that we did it, we can now go ahead and use the shortcut formula for y-intercept. So y-intercept is a sub y is equal to the mean of y minus the slope multiplied by the mean of x. So obviously here we're going to have to calculate the mean of y and the mean of x. We already have the b sub y. And those are, of course, easy to do. 759 divided by 14 to give us the mean of x, 42.1 divided by 14 to give us the mean of y. So I'm not really going to pause here. I think that that's fairly easy for us to do. So it should be our formula for the y-intercept, 3.01 minus the quantity 0.038 multiplied by 54.21. Go ahead and solve for that, and then come back and we'll compare our answers. All right, again, at this point, I'm expecting no errors. Most of the errors coming in the getting the column set up. So really not much of a mistake likely to happen here. So our y-intercept should be 0.95. And we're going to take those, both the slope and the y-intercept, and plug them into the regression formula. So our least squared prediction line is always y prime, the prime indicating that this is the prediction line, is equal to b sub y, the slope, multiplied by x plus the quantity of the y-intercept, a sub y. And then plugging the values in, it is 0.038 multiplied by x plus 0.95 to go from the number of problems from this data set into an expected GPA. So that's always the answer for the regression line. So it's typically part A and then part B. This would be the answer to part A, is that the line that's sort of there with the values plugged in. That is the final answer for what is the regression line. Then, of course, there are additives. So now someone new is coming in. We have a value on them for how many problems did they do over the course of the year. And we're now going to solve what would their likely GPA be if they follow the same pattern of data as the other or the rest of the group of people. So in this case, we now have an expected grade we're predicting for a student who did 43 problems over that same time period. So what we're going to do is take that 43, plug it in as a value of x, multiply it by 0.038, and then add 0.95, and that would give us the predicted value for this individual's GPA. I'll pause again, or you pause again, I can't do it for you. Pause and solve with that 43 in for x, and come back and we'll look at the final answer. All right, what happens when we plug in 43? You should have ended up with a y value or y prime value of 2.58. So based on the original data, which creates the regression line, a new student coming in who did 43 problems, we would expect their grade in the class to be a 2.58, so a mid-C range, an average score for that particular student. All right, and as you saw with the first walk through the problems, that's really it. There's not a lot of heavy lifting on this one other than the multiplication and addition of a larger data set. So that is regression for you. Again, that's our number 2 example, which means that you're going to have a short video today, which is astounding. And don't forget, of course, homework number 4 is ready for you as well. I hope you have a great week. I will leave another video for you, or notes at least, for Wednesday's class. Have a good one. Oops, as soon as I can get out of this. Da, 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 da.